Alright guys, so today we're going to be starting on Unit 5. The first little section we're going to talk about is ratios and proportions. So ratios and proportions you've actually talked about and learned in middle school, so this is just a quick little review before we bring triangles and other shapes into the mix. So first and foremost, just remembering what a ratio is. It is a comparison of two quantities using division. So you're going to compare two quantities and it's going to implement division. So there's three different ways you can look at a ratio. It's either written as A to B, A colon B, or A over B. B cannot equal 0. The important thing is you want to write your ratio in the order it's stated, okay, because that's going to keep everything aligned and straight. Okay, also ratios are usually expressed in simplest form. Basically reduce your fractions. Okay. Ooh, whoops. Fractions. My bad. So if you're looking at aspect ratios, 32 to 18 and 16 to 9 are equivalent because you have the width of a screen and the height of a screen. This would be maybe like a TV. 32 to 18 units or inches. If we were to simplify that, we can factor out a 2 or divide by that 2, giving you 16 to 9. So whether you have 32 to 18 or 16 to 9, they are the same. 16 to 9 is just the more simple form. Okay, so as far as sports go, ratios in the real world of sports, we're told that a baseball player's batting average is the ratio of the number of base hits to the number of at-bats. So I want to make an example of that, okay? So number of base hits. Remember, a ratio can be written as a fraction. Number of at-bats. Okay. The table at the right here shows Ian Kinsler's career batting stats with the Texas Rangers. We want to know his overall batting average. Okay, so we need to set up that ratio using his total numbers. Okay, so thinking about the ratio we have the number of base hits, which is 1145 over the total number of at-bats, okay, or 4201. All you have left to do now is just to reduce that fraction. So 1145 divided by 4201 is 0.2725. Okay, when you have a batting average, typically it's just written as 3 decimal places. So his batting average is about 273. Okay, so moving forward, we have our next example. So we want to look at the ratio of the measures of the angles in a triangle. Okay, we're told it's 3, 4, 5. Okay, we want to find the measures of the angles. Well, in order to do that, we're going to think about a triangle. So we know that the ratio of those angles is 3, 4, 5. Okay, the ratio is 3, 4, 5, not the measurements. In order to find the measurements, we have a missing factor, okay? 3 times what? Okay, we can say that 3x, 4x, and 5x would be the ratio of the actual angle measurements. Okay, it's the same exact thing. So, thinking about a triangle, we know that a triangle has 180 total degrees, okay? And we know that by our triangle sum theorem, all 3 angles, 3x, 4x, and 5x, have to add together to equal that total of 180. So what we're going to do, we're going to say 3x plus 4x plus 5x, okay? So we're adding each angle measurement together. They have to equal 180, okay? So in order to find the actual individual measurements, we need to first solve for x, okay? So we're going to have 12x equals 180. And then after we divide by 12, we get x equaling a total of 15. Okay, now the measurement of the angle itself is not 15, that's just the x. So we need to plug this x back in. So 3 times 15, 4 times 15, and 5 times 15. Okay, so the ratio of our measurements, or when we solve the measurements themselves, we'll get 45, 60, and 75 degrees. Okay, so this measurement aligns with our ratio, and then to double check, we can say that in order for this to be true, they need to have a sum of 180. So 45 plus 60 is 105 plus 75. When you add them all together, it equals 180. Okay. All right, so the next example, I showed you guys how to set this up in class. And then just to solve it out, we have 3 sides of our triangle. We have 9, 7, and 5 per our ratio. The perimeter is 191.1, so that's the total. Okay, we can say that if the ratio is 975, then the actual measurements, 9 times the missing value, 7 times the missing value, should be the same. Okay, so the perimeter is the distance around, right? So 9x plus 7x plus 5x equals 191.1. We're going to get 9, 7, 16, 21x equals 191.1. And then when you divide that by 21, x will equal a total of 9.1. Okay? So if we were to plug 9.1 back in for this x, okay, 9 times 9.1, 7 times 9.1, 5 times, it should add up to be 191.1. Okay? So moving past just a ratio, now we're going to look at proportions. So the only difference between a ratio and a proportion is the fact that a proportion is just 2 ratios that are equal to each other, okay, set up in an equation, okay? So A and D are called your extremes, B and C are your means, okay? Anytime you multiply your extremes and you multiply your means, this is called cross product, okay? These products are equal to each other, okay? So what that means, if A over B is equal to C over D, okay, so if this ratio equals this ratio, we have a true proportion, then by the cross product property, we know that multiplying across 4 times 15 should equal to 10 times 6, okay? So what that looks like in an example, we have this proportion here, 6 over x equals 21 over 31.5. We're going to cross multiply, so we get 21x equals 31.5 times 6. Okay, so when we simplify and solve for x, we get 21x equals 189. And then last step, we divide by 21 to get that x isolated, leaving us with x as a value of 9. Okay, so in order to check that work, to see if our proportion is in fact true, we're going to plug in our x value back into our proportion. Okay, so for our check, we would say 6 over 9 equals 21 over 31.5. And if we did this right, our cross products, 9 times 21, would be equal, okay? 6 times 31.5. So remember, 6 times 31.5 earlier was 189. Okay, 9 times 21 is in fact 189. Since both of these are equal, we solved it correctly. Okay, so one more example like this. So even though we have little variables involved, little extra variables, it's the same concept, okay? So we just need to multiply. So 5 times x plus 3 equals 2 times 4x. Okay, we're going to distribute this 5 to get us 5x plus 15. That is going to equal 8x. Okay, we are solving for this x value, so we need to get our x's on the same side. We have 15 equal to 3x, and then isolating that x will give us a total of 5. So if I was to plug this 5 back into this equation, okay, then we would see that the cross products are equal. Okay, our last example here, we have a word problem. Okay, so car ownership. Fernando's conducting a survey of 50 students driving to school, and he finds that 28 of those students own cars. Okay, I'm going to underline these because they're probably going to be pretty important information. So 50 students are driving and 28 own cars. If 755 students drive to his school, we want to predict the total of number of students who would own cars. So, driving, 755 driving, remember driving earlier was pink, okay? The total number of students who own will be blue. That's what we're trying to solve for. Okay, so most important thing, write and solve a proportion that compares the number of students who own cars, okay, remember that was our blue, to the number of students who drive to school, okay? So when we're writing these proportions, these ratios, we want to write them in the order they are stated. So the number who own over the number, oops, that's supposed to be pink, number who drive. Okay, so when Fernando conducted his research, he discovered that 28 out of 50 students who drove to school owned cars. Okay, and then we're trying to predict if 755 students drive to school, how many will own cars. Okay, so we have our proportions set up. Thinking back to earlier in the notes, we want to reduce this ratio if at all possible, okay? So this 28 over 50, I can actually reduce that by factoring out a 2. So I'm going to show you how to do that, okay? If you can do this in your head, that is quite all right. So we have to factor out that 2, which is going to leave us with 14 over 25. So reducing our ratio, reducing or simplifying our ratio is going to just give us smaller numbers to work with. This will really come in handy when we're working with areas and perimeters a little later on. So I want to use 14 over 25, okay? So now I just need to solve for x, okay? So we cross multiply, 25x equals 14 times 755. Right, when you simplify that answer out, you're going to get a total of 14 times 755, 10,570. Okay, and then because we're solving for x, we need to divide by 25 on both sides. And that is going to be a total of 422.8. Okay, so realistically, you're not going to have 0.8 of a person owning a car. So we can say that roughly or approximately 423 students would own cars if there was a total of 755 driving. Let me know if you need any help. Good luck, guys.